Explore primary ingredients of Kubernetes. Hello folks, I am Shivam Jaiswal. I am a tech enthusiast and a working professional back-end software engineer. There are certain prerequisites for this tutorial as it talks about intricacies. Viewer ought to have prior knowledge of Kubernetes, containers, interfaces and classes and their mutual relation. Have you ever thought, what is the basic constituents of Kubernetes? What if some of its components gets deprecated? Will Kubernetes get ceased to exist, or is it flexible enough to replace some of its components without much hassle?
Let's get started.
We always hear this terms loose or tight coupling, so let's explore first what is loose coupling. Loose coupling is a design principle in software development which aims to make the system, components more independent and flexible. It is achieved by the introduction of well-defined interfaces, so that the underlying component can be changed without affecting the core functionalities. That is what Kubernetes also uses internally, quote-unquote, the interfaces. Now it is relevant to ask, what are these interfaces and does all the components which is used by Kubernetes like runtime engine like Docker or Containerd etc. implements these interfaces? The answer is yes, all the components of Kubernetes are replaceable or pluggable by the components which follows certain open standard interfaces given by Kubernetes community. Let's understand these interfaces. CRI Container Runtime Interface, CNI Container Networking Interface, CSI Container Storage Interface, SMI Service Mesh Interface and CPI Cloud Provider Interface. Let us explore each of them one by one. CRI is a crucial component that allows the kubelet, or the agent running on each node in a cluster, to interact with various container runtimes. Think of it as a standardized language between the kubelet and the container runtime engine. Container runtime can be any application which is used for running and managing containers. There are many runtime engine available like Docker, Containerd, CRIO, RKT, etc. The interesting part is that we can select any of them on the basis of our need and flexibility. CNI is a framework for dynamically configuring networking resources for containers. It acts as a bridge between the Kubernetes network model and the various container runtimes like Docker or Containerd etc. It allows you to choose from various networking options, simplifies network configuration, and provides a consistent way to manage your container network environment. There are many options available like Calico, Flannel, Weave, and Cilium. It can be used as per the need for handling the network traffic. CSI focuses on providing standardized access to storage for containerized applications. AWS S3, Azure Blob Storage, Google Cloud Storage, and on-premises solutions like Ceph and OpenZFS are some of the examples. This ensures consistent and reliable communication between Kubernetes and different storage providers, regardless of the specific technology used. Kubernetes doesn't have its own built-in storage management system. Instead, it relies on CSI drivers, which act as plugins, to provide access to various storage solutions. These drivers handle tasks like provisioning volumes, mounting them to containers, and managing lifecycle events. Before understanding Service Mesh Interface, let us first understand what is Service Mesh. Service Mesh is a dedicated infrastructure layer that manages communication between microservices in a distributed application. Think of it as a network of invisible tunnels specifically designed for microservices to talk to each other secure and efficient manner. Now let us understand SMI or SM interface. In Kubernetes it is like a translator for service meshes. It allows different service meshes to speak the same language, making it easier to manage and use them in your Kubernetes environment. It provides a set of standardized APIs for common service mesh tasks like traffic routing, security, and observability. This means you can use the same tools and configurations with different service meshes, without needing to learn new languages for each one. The Cloud Provider interface replaces the Kubernetes Controller Manager for only the cloud-specific control loops. The Cloud Provider breaks away some of the functionality of Kubernetes Controller Manager, KCM, and handles it separately. Here cloud-specific control loops refers to automated processes and feedback mechanisms that are integral to the management, optimization, and orchestration of resources and services in cloud computing environments. This interface is needed to use resources or services of public or private cloud in the Kubernetes environment, as there are many things to be handled when we are consuming resource of public cloud like specific zone, region, availability, etc. Thanks for attending this tutorial attentively. This tutorial was just an introductory level course covering some of the basic concepts. If you want to dig a little deeper and interested in exploring similar contents, then hit the subscribe button to stay updated. Feel free to also reach out to me over my email address mentioned here. Thanks folks. See you again soon.